A-level statistics, permutations. Let's have a look at permutations. Suppose we've got a set of objects and we take a selection in order from the set. Then this selection is called a permutation. Let's look at an example. In a race with 8 candidates, there will be 3 medalists. A gold who comes first, a silver who comes second, and a bronze who comes third. There can be many different results depending on how fast each competitor runs. Now the total number of permutations is called NPR, where N is the number of contestants and R is the number selected, in this case the number of medalists. So in this case the number of permutations is called 8P3. There are 8 contestants who could come first. There are then 7 contestants who could come second, and finally there are 6 remaining contestants that could come third. So the number of permutations is 8 times 7 times 6, which is 336. Now this is 8 times 7 times 6 times 5 factorial over 5 factorial, or 8 factorial over 5 factorial, or 8 factorial over 8 minus 3 factorial. Now similarly, we can show for any value of n and r, NPR is equal to n factorial over n minus r factorial. Let's look at an example. Suppose I have 15 pictures and want to put 5 of them in order along a wall. Now I have a choice of 15 for the first place, then a choice of 14 for the second place, and then I have choices of 13, 12 and 11 for the next 3 places. This means there are 15 times 14 times 13 times 12 times 11 possible permutations, which is 360,360 permutations. Now this could be written as 15 times 14 times 13 times 12 times 11 times 10 factorial all over 10 factorial, which is 15 factorial over 10 factorial, or 15 factorial over 15 minus 5 factorial permutations. Again, we see if we select R objects in order from a set of n objects, the number of permutations is given by NPR equals n factorial over n minus r factorial. So let's see in an example how many ways it's possible to arrange 3 different vowels. Well, to solve this, we're selecting 3 letters out of 5, that is A, E, I, O or U. So the number of permutations is 5P3, which is 5 factorial over 5 minus 3 factorial, or 5 factorial over 2 factorial, which is 5 times 4 times 3, which is 60. So there are 60 permutations. Let's look at another example. How many different permutations of 5 letters could we make from the letters A, B, C, D, E, F, G, H and I? Well, to solve this, we've got 9 letters altogether and we want a permutation of 5 taken from those 9. So that will be 9P5, which is 9 factorial over 9 minus 5 factorial, which is 9 factorial over 4 factorial, or 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial. The 4 factorials cancel, and that gives us 15,120. Now, note there is an NPR button on most scientific calculators, although it's usually a shift key. So in this case, using a calculator, simply type in 9 NPR5 equals, and we get 15,120. Now in part B, it says from the same set of letters, how many 3-letter permutations could we make? Well, we want 9P3, which is 9 factorial over 9 minus 3 factorial, or 9 factorial over 6 factorial. Well, we can work it out as 9 times 8 times 7 times 6 factorial over 6 factorial, and the 6 factorials cancel, so we're left with 9 times 8 times 7, which is 504. Let's look at another example. From a class of 15 boys and 12 girls, 3 boys and 2 girls are to sit in a row for a debate. In part 1, we're asked how many possible permutations are there. Well, to solve this, 5 children must be chosen from a class of 27. So the number of permutations is 27p5, which is 27 factorial over 27 minus 5 factorial, which is 27 factorial over 22 factorial. So we can write it as 27 times 26 times 25 times 24 times 23 times 22 factorial divided by 22 factorial. The 22 factorials cancel and we're left with 9,687,600. Now in part 2, we're asked if they must alternate boy, girl, boy, girl, boy along the row, how many permutations are there? Well, first of all, 3 boys must be chosen from 15 to sit in the 3 chairs, and then 2 girls from 12 for the other 2 chairs. So the number of permutations is 15p3 times 12p2, which is 15 factorial over 15 minus 3 factorial times 12 factorial over 12 minus 2 factorial, which is 15 times 14 times 13 times 12 factorial divided by 12 factorial times 12 times 11 times 10 factorial divided by 10 factorial. The 12 factorials cancel and the 10 factorials cancel, and so we're left with 360,360. Now we may get a permutation problem with some additional restrictions put on it. So, if there are some restrictions placed on a selection, these should be considered first. For example, a chess club has 15 members, of which one is the captain and another is the vice-captain. All others are considered equal ranking. They need to select a team to play on tables 1 to 8. The highest ranking player taking part must sit at table 1, and the next highest ranking player must sit at table 2. How many ways can they be arranged? Well, to solve this we need to consider 4 cases. In the first case, the captain and the vice-captain take part. The captain and the vice-captain must sit in positions 1 and 2. Now there are 6 remaining seats and 13 members to choose from. So the number of permutations is 1 times 1, that's the captain and the vice-captain, they have no choice, times 13p6, which is 13 factorial over 13 minus 6 factorial, or 13 factorial over 7 factorial, which is 1,235,520. In the second case, only the captain takes part. Now the captain must sit at table 1, and there are 13 members from which to select the other 7 players. So the number of permutations is 1 times 13p7, which is 13 factorial over 13 minus 7 factorial, or 14 factorial over 6 factorial, which is 8,648,640. In part 3, if only the vice-captain takes part, then the vice-captain must sit at table 1, and there are 13 members from which to select the other 7. So the number of permutations is again 1 times 13p7, which is 8,648,640. Now the last case, neither the captain nor the vice-captain take part. And now we've got 13 members from which to select 8. So the number of permutations is 13p8, which is 13 factorial over 13 minus 8 factorial, or 13 factorial over 5 factorial, which is 51,891,840. So the total number of permutations is the first case plus twice the second case plus the fourth case, which is 70,424,640. And that's our answer, 70,424,640. 640.